As where where we had left off, we had two statistics that we were introduced in the start of 14.2. The Pearson's product moment correlation coefficient and Spearman's statistic. Remember that the difference between the two is the Pearson statistic is strictly for linear relationships. The Spearman statistic is just for overall increasing or decreasing relationships. So before we move on and kind of continue, let's talk about outliers and their effect on either of these two statistics. So let's say we have the following scatter plot or the following data set. What do you notice when you look at this thing? Yeah, it's a pretty obvious outlier there, right? Yeah. So in general, we notice that this graph has a negative trend, right? We'd expect the Pearson statistic to be a negative R value. But what did we actually get when we calculated it? Positive. Why?
Yeah.
The stupid outlier is getting in the way, right? And gumming everything up. So that one outlier changed the entire trend from negative to fairly strong positive. But like positive trend is like bananas, right? No one's actually going to think that that's the relationship going on in this data set. On the other hand, if I look at the Spearman correlation for this, even with the outlier, what do we get? I get a negative relationship still. And that makes sense, right? The takeaway here is that Spearman's statistic is not as strongly affected by outliers as the Pearson's, where the Pearson could be very heavily affected by outlier in so much as like not only is the correlation off of maybe where it should be, but the entire direction is wrong because of that outlier. You're not going to get the direction wrong with the Spearman. You can still have, like a better correlation without the outlier, but you're not going to lose the direction aspect with the Spearman just because of an outlier. Okay, we said that. So monotonicity, this is a fancy mathematics word for staying the same or increasing and or staying the same or decreasing. So something that's like doing this is monotonically increasing. Something that's like doing this, monotonically decreasing. Okay. So it's just the same idea as increasing or decreasing with the added caveat of and staying the same. So here again, examples of things that are increasing and decreasing. We know that, I think. So the thing that Spearman's correlation is not going to do well with is things that are not monotonic, either increasing or decreasing. So things like this, look at that wacky-do, right? We're increasing, then we're decreasing, and we're increasing again. Here we're increasing, and we change to decreasing. Same thing here, we're decreasing and change to increasing. These things, the Spearman correlation is going to not do a good job of representing, but the Pearson might still. So our takeaway, Spearman's going to do well if there's outliers, and the overall trend is still monotonic, as opposed to Pearson, which is going to struggle with outliers, possibly. But if you have something that's not monotonic, that's both increasing and decreasing, there the Pearson might still do well, the Spearman will not. So that's kind of your takeaway about like, when should I use which one? Feel okay? All right, I think that was the end. There's less slideshow left than I thought I remembered, but that's okay. Nobody's going to complain about that. All right, so let's take a look at some of these in-class examples here. So we did that one already. I'll put the answers in a second for the 14-1. All right, let me get out my random student chooser. You'll probably want your calculator because that's how you're going to be using your
Wonderful students team. Those kids like super advanced. Good. That's like 2001.
it's the operating system. Don't.
I think
Yeah.
you could.
It may be a function, though, of the memory, in that calculator may not be sufficient to load the new operating system, though. That's the other thing I might be concerned with, but it's entirely possible you could do that. Okay, Gavin, you're going to be our starter.
Let's go, Gavin.
All right. So each member of a statistics class ran a 40-yard sprint and then did a long jump after their sprint. The table below shows the sprint time in seconds and the long jump distance in inches. Make a scatter plot of the relationship between the sprint times and the long jump distance. Explain why you chose your independent and dependent variables and what scales you used. So I'll plug this into the calculator to get the scatter plot. Gavin, what I want you to talk about is, if you're drawing this by hand, first, which one you counted or which one you would view as your independent versus dependent variable and why, and then how you would scale the x and y axes. So which one of these?
Sprint times independent and long jumps dependent.
Okay, and your reasoning there is?
Is a long jump after the sprint, so it depends on how they did the sprint.
Okay. Track and field aficionados in the room, what would you say? Independent, dependent variable based on running speed or 40-yard dash time, and then long jump distance. Which one should depend on the other? Yeah, because I agree, that's the same thing Gavin said, but what's your reasoning there?
You run faster, you go far.
Yeah, there. That's ostensibly how most of the field events work. Is you're translating horizontal velocity into into force on the long jump board, or distance into the shot put, or whatever your event is. To some extent, all of the track and field events are like the fastest person in the sprint wins. But yes, I agree with that, Gavin. Looking at the numbers here, how would you scale your x-axis? What number would you start at, and then how much would you go up by? Okay, 0 to 10, and you go up by how much?
1.
It feels pretty rough trying to plot like 7.01 and then 17.1 or 7.17 and 7.25 all in.
0.5.
Go by 0.5s.
How big is it going to be?
I'm asking you.
Excuse me, 0.25.
I'll tell you what I would do. I would start at 5, and I would go to 8, because that's going to cover all the times. And I'd probably go by tenths. And that's 30 tick marks, but that's not absurd if you're putting it on a sheet of paper. How about for your y-axis with your long jump?
So 65 for like 175.
Well, probably higher than that.
185.
Yeah, I might go 50 to 200 or something and go up by 5s or something. That seems pretty reasonable there. But that's all we're talking about. So I went ahead and typed these into the L1 and L2 in my calculator. And to graph this on my calculator, I press second y equals. For plot 1, I turned on. I'm going to select the scatter plot option and then use x's as L1, y's as L2, and make my mark the square. I like the square. And then to graph this, I'm just going to press, oops, I guess I have to exit out of there. And I'm going to press zoom statistic or zoom stat. There it is. And that'll automatically scale my x and y axes. Oops, had something in my y equals. That automatically scales my x and y axes for me. Anybody need to see that again? So I started by typing in my data into L1 and L2. Right? We don't need more detail on that. We've done that a million times, right?
Yeah.
After I've done that, I press second y equals, and then I'm going to graph a scatter plot, I'm going to turn on, say, plot 1. The scatter plot option is the first option from the type. It's the one that looks like dots. I'm going to make sure my x's are L1 and my y's are L2, as we discussed. And I usually like the squares because they're easy to see. And then if you exit out of there, to graph this, I'm going to just press zoom and scroll down and pick the stat option. That will automatically scale my x and y axes so the data fits appropriately. You don't have to think about it real hard. So that's our picture, right? Okay, next up is Christian. Describe what the scatter plot you drew reveals about the relationship between sprint times and long jump distances for students in the class. Describe the relationship in terms of direction, strength, and form. Let me put that back up there so you can see it.
Are these two separate questions, or is this like...
No, it was all the same thing.
Okay.
Just strength, direction, strength, and form.
So it looks to be negative.
Agreed.
I'd say it's strong or moderately strong.
I'll agree with that.
And then the form would be linear.
Linear.
Yeah.
Well, it's like clearly looks like a straight line, right? It's just kind of like a thick straight line. So that's pretty strong. It's not outstandingly strong because it's not like a thin line. But I'd say if you can tell it looks like a line and it's just kind of a thick line. Did you press zoom stat? Did you turn on the plot? Okay, after you turn on the plot, just press zoom stat and it'll give you a decent window and put it on there for you. So, okay, so that was good, Christian. Thank you. Next up is going to be Isaac. Part C says the scatter plot has a correlation value of R equals negative 0.838. Interpret this value of R in the context of the data.
that spin speed and long jump are like relatively strong.
With a negative association. Good. Yeah. So strong negative association is the most compact way you could say that. Yep. You could say just it's strong because the R value is close to 1 or -1. It has a negative because it's a negative value, and you just say association. Would be fine. What's up?
What's the association?
That means like a functional relationship, like a, like as, in our case, as the sprint time is going, getting lower, right? The long jump distance is getting higher, right? As one is, so that's what we mean by the association.
Okay.
Just mean like a one-to-one relation, like a linear relationship, kind of like that. And you could say linear association there because it's a Pearson statistic that you have. How do I tell that this R value is a Pearson value, not a Spearman value?
Yes.
There's no subscript on it, right? The Spearman statistic will have a subscript S on the R. The Pearson will not. Okay. Based on your scatter plot, what effect does the person who ran 7.7 or 7.25 seconds have on the correlation? Justify your answer. And the person going to be doing that is going to be Lexi. So it's saying this spot right here, that's the person that ran the 7.25 seconds. What effect is that having on the correlation? Is it making it better or worse? Why or why not? Okay. Well, the way I would look at this is that's a slow time, right?
Yeah.
But that's a pretty far long jump distance for somebody that's running so slow, right? That they're jumping further than like these people that all ran faster than them.
Yeah.
So my suspicion is that by removing that point, your correlation would improve because you'd have more that strong negative relationship. I'd expect the R value to go, closer to -0.9. But that would be my justification, is that this is a fairly slow person that's jumping pretty far, that that's kind of an outliery point.
Yeah.
If I drew in a best fit line, it looks something like that. That's pretty far from the best fit line.
Yeah.
If I ignored him, the best fit line would be even tighter. That would be kind of my explanation there. That's what I would be looking for to answer that kind of a question is, does that point lie close to a best fit line or not? If it's close, then it's probably, like just supporting what's going on. If it's far away, like this one kind of looks, I'd suspect that removing it will improve your correlation. So it's hampering it to some extent. Okay. Each member of a small, same problem going on. Part E says, calculate the value of R using the formula below. Be sure to show an appropriate amount of work. And we know what the R value is, right? Zach. What are the symbols in this formula saying?
So you gotta divide 1 over n.
Okay, what's n?
N is reverse.
Reverse.
Not reversed, it's the number of samples.
Oh. 12.
That's what I counted.
1 over 12.
Okay. So that's so far so good. Keep going. What are the rest of these symbols saying?
The x is x.
That's well, one is x and one is x bar.
Yeah.
What's x bar? It's the average of the x's.
So you gotta add all of them up by 12.
Uh-huh. And then what is this symbol? Well, you know what? This is just helping, right? Like we didn't know this before. We're going to force to learn it now because that's the standard deviation for the x's.
It's the same thing, so y is just the long term 1.
Mm-hmm.
So it's just, I'll add them all up by 12, and then standard deviation of y.
Yep. So if I wanted to do this by hand, the first thing I would need to do is figure out the x mean, the y mean, the x standard deviation, the y standard deviation, right? What's the easiest way to do that? Great. How am I going to do that in my calculator?
Plug it in. Stat. 2 variables. Stat, edit.
I'm going to do the 2 variable statistics. So stat, calc, and I'm going to do 2 variable statistics. So it gives me my x mean, it gives me my x standard deviation, it gives me my n, it gives me my y mean, it gives me my y standard deviation. All that's here for me, right? Okay. So now to calculate this stuff, the easiest way to do that is I'm going to go here into my menu, and in L3, I'm going to move up so I'm on the title L3 and press enter. And I'm going to type this kind of thing in. So I'm going to do parentheses, and then I'm going to do x, which is my value from L1, minus x bar. How did I get the L1? Second and the number 1. See the little blue L1 above it? Now to get the x bar, what I'm going to do is I'm going to press the vars button, and I'm going to go down to the statistics option, and I'm going to pick x bar. And then I'm going to do divides by, and I'm going to go back to vars, statistics, and this time I'm going to pick the sigma x. And I guess I probably should have put a parenthesis in here. So I'll insert another one of those so I don't have to retype everything. And then just go back and do the same thing. So back to statistics. This time I'm picking the y bar. And then divided by the sigma y. And then I'm press enter and hope that worked. Yeah, it looks good. Everybody's okay? So we have all these values, right? What I need to do now is I need to, the big sigma here means to add those all up, right? What's going to be the easiest way to do that? calculator, but how on my calculator? I'm going to do a one variable statistic on L3 because one of the statistics I get is the sum. So I'm going to exit out of here and I'll go back stat, calc, one variable statistic, but I'm going to do that on L3 because one of the things I get is the sum right there. So now I'm going to do 1 over 12 times, and I'll go back to vars, statistics, and I'll move over because I want a sigma statistic, and I want just that sum of x's. And there is my -838. Now, if I was writing this down, Zach, if you're doing this on like the IB exam, all I would do here is I would just do this for like one data point, and I'd fill in whatever my means and standard deviations were. I'm just going to leave that stuff blank because I didn't write it down. And then I would just do ... And then I would do it, with the last one. And like that's enough work. So you see what we did was we took the first x and put it into the formula, and then like the first y and put it into the formula, and we did like the last x and the last. You can just do the first. As far as showing work, just do the first and last and put like a ... in between, because like nobody has time to write this whole thing. I mean, even at just 12 data points, this becomes like really overwhelmingly tedious. Nobody has time to do that. Just kind of give the impression that like, hey, I know what to do, and then we're doing the rest on our calculator. Now, in practice though, when I'm calculating an R value in my calculator, I'm not even doing this. Like you could do this to show work or whatever, but I'm not doing this. There's an easier way to do it than this, than using the formula. So what I'm going to do instead is I'll press the stat button, I'll go to calc, and I'm going to pick linreg. I'm going to do that with L1 and L3, and then I'm just going to hit calculate. Okay? And there's my R value right there. That,
Can you go over what lines we're supposed to put to take into account?
That's gonna be like a whole separate thing because I'd have to like completely redo it because I can't go back, and once I've typed it and pressed enter, I can't. If I just press up here, it just shows the list of the data that's in there. It doesn't show the formula that I made to get that data. But we can talk in a minute because all we're doing today is finishing this, and I can certainly do it again, unless everybody wants to see it again.
For the linreg to get the R.
Oh yeah, how many of you guys did the linreg and didn't get an R value to pop? Yeah, so everybody should do this on their calculator. Even if their R value popped, it makes no difference, because if it doesn't, you should know how to do this in case your calculator gets reset and this option gets turned off. So to make sure the R value pops when you do your linreg, what we need to do is make sure the diagnostic is on. The easiest way to find that command is to press second and then the 0 button. That's the catalog. And the catalog is arranged, it's every command in your calculator in alphabetical order. we want to find the one that says diagnostic on. So rather than scrolling all the way down to the D's, I'm just going to press the button with the green D above it. That'll skip me all the way down to the D's. And then I'm going to scroll till I see diagnostic on. I'll press enter to select the command and then enter to execute it. If you rerun your linreg now, you will get R values to pop. If you have to reset your calculator's memory for whatever reason or your battery dies,
So that's like the way you used to do it.
if I just want the number, that's the way that I would do it. Because it's like 3 buttons as opposed to like writing in this whole formula and doing these sums and like,
Yeah. You can just write that and then,
you can show the work and then just use your calculator to get the number.
yeah.
And you don't have to do all the intermediate stuff that we showed you how to do. Shh. All right. Next question says, recall that the data point 7.25, 110 made our calculation weaker. Recalculate the R value without that point to see if it makes the correlation better or worse. Elise, this is yours. So what are we asking you to do? Saying remove the data point 7.25, 110.
So then you, is there anything to add in L3?
L3 doesn't matter. Because how am I going to calculate the R value after that? Stat, calc, linreg, L1 and L2, because now I've updated L1 and L2 not to include that point. Look at my R value now.
So is that,
Got a little bit better, right? Got a little bit closer to -1, as we expected. That's it.
so should you say, explain that it got closer to -1 or no?
Well, it just says that the directions just ask you to recalculate the value of R, which we did, and see if it makes our correlation better or worse. So because we got closer to -1, it's better, right? And that you could say simply that it's better because it's closer to -1. And that would be fine. All right. So, next one says to put the data into rank order. Make sure you're including still the point 7.25. Oh, Aiden's gone. Matt, you're up. So it wants us to sort this into rank order. But we need to put this point in that we took out for the previous problem. We need to put that back in. What's up?
I don't know his question.
So it's part G. Put the original times and distances in rank order. So that's a start. Let me go back and pull this back up for a second. So you'd start by sorting the X's and Y's. Oof, you don't want to sort both the X and yeah, you just want to put them in. So this is what I would do. This is how I would do this, Matt. Is I'm going to store into I'm going to store into L4, L1. And then I'm going to do math. Where is it? Where are you? There's a sort command here somewhere. It is in stat? Okay. Stat edit? Was it edit? Oh, I'm so dumb. There it is right there, staring me in the face. Okay, and I'm going to sort L4.
How do you put in L4?
I press second and the number 4. See above the number 4 is the blue L4.
Oh, and then what did you do in L4?
I just copied L1 into it.
Actually, just deleted it all, so.
So if I go back and do this now, I remember that from the notes, we start with the smallest value is the biggest number, and the biggest value is the smallest number. So this 505 would be 12. Oops, let me move this around so I can see it all on one screen. And then 541 would be 11. And then 568 would be 10. And 578 would be 9. And 631 would be 8. And 644 would be 7. And then 650 is 6. And then 673 is 5, and 680 is 4, and then 3, 2, 1. Everybody's okay there? And then I'm going to, in L5, I'm going to put in the data for L2. And then I'm going to sort that data. And go back. Trying to think if there's an easier way to do it than the way I'm doing it, but I don't think there is. So again, smallest is the biggest number, so 12, 11, and then 10, 9, 8, 7, 6, bless you, 5, 4, oops, 3, 2, 1. Yes, Elise.
So for L5, do you have to, okay, so for L4, you sorted it from the top, the smallest to biggest, and then L5.
I sorted it the same way.
Wait, why am I going to do biggest to smallest?
You must have picked sort D for descending instead of sort A for ascending, but it doesn't really matter. In fact, descending might have been easier because then you could just start at 1 and just keep counting.
So it doesn't really matter.
It does not matter. I just wanted them in order so it would be easier to figure out like what order they should go in when I do the numbering, because the way they're written on there was not helping me any, right?
Yeah, no.
It was just going to be a hassle, time consuming. Okay. So now what I'm going to do is I'm going to go back in here and clear out L4 and L5. In place of L4, I'm going to do the rank order for the X's. So 11, 12, 3, 2, 5, 10, 9, 8, 7, 6, 4, 1. And I'm going to do the same thing for the y's now. So 3, 1, 10, 12, 11, 6, 4, or 2, 4, 9. I'm going to stop talking because if you're typing too, this has got to be driving you nuts. Everybody's okay there?
Can you list? L4 again?
It's these numbers right here.
Just that?
Yeah, I just typed in those numbers. So that's just the rank order for the y's. I just typed them in that order
That you have.
that I've written there. So 3, 1, 10, 12, 11, 6, 2, 4, 9, 5, 7, 8. Alexis, you're making some faces.
Yeah, I can't really see.
Can you not read my penmanship?
No, I just said it's not there.
Oh, you can move closer if you need
Should
to.
we put the values that we took out that we'll come back in? Yeah.
What? I'm sorry. What's going on now? No, I don't need any new values.
We took the.
Oh, yes. Yeah. I put them back in when I did this. If you didn't put them back in when you did it,
What were the-
it was the last pair of points. Now that I've gone and created a rank order for these, what do I do next?
Graph them.
Nope.
No.
I don't need to graph them. I could if I wanted to, but I don't need to.
For the R.
I just need to calculate the R using my rank order lists. So I'm going to do that same linreg, but I'm going to do it on L4 and L5 to get the R value for that.
Yay.
Okay, so we got about negative 0.797. You guys get that too? Good. All right. Question 2 is the exact same kind of question. Try it on your own. I'll put like 15 minutes on the clock or something, or 20 minutes on the clock, and then we'll run through the answers. Okay, so take out a sheet of paper, get your calculator fired up, feel free to talk to each other, but work through the problems here, or this example problem 2. Which is really kind of the same thing that we just did, right? It's like the same parts as question 1. Maybe they eliminated a question or 2, but it's like the same idea. Sound good? Okay. This calculator literacy piece that we're doing right now, hugely important on all these tests, right? This class really boils down to, can you use the calculator effectively? If you can do that, you're going to be in very good shape. It's very much a calculator literacy course because most of this stuff we don't need you to be able to do by hand. Well, I guess for that first question, you need to hear the story, right?
Yeah, I agree.
I'm already had questions.
Boil. God, I really just want to boil right now.
Are you sure? This is right.
I'm gonna say math is like numbers. You need to substitute.
All my like classes right now are kind of overlapping on like what we're doing. Pretty much a cockpit. Definitely something like buyout in this. So like, just like please talk to them.
I know. Oh, you lost me there. So you put all the values in. I don't really know what height is for X, right?
What's your favorite type of math that you struggle with?
I like them all.
Like them all?
Yeah.
Too many good ones to choose from. I feel like you're too smart to teach all the
And you
math.
can't figure it out.
I will.
No.
I think what you're saying.
Yeah, you literally carry
Trust
this
me, I
math
will.
on it. Yeah,
I think we have a lot of good teachers in our department right now. I think the new people we've hired over the past couple of years, I think, are very good teachers.
Probably better than one of us.
That's very true because we're getting students than we teacher.
I think he does a very nice job. I've sat in and watched him a couple of times.
What? Gavin, or Mr. No, Mr. Who's in formula?
And I think Mr. Myers seems like he's doing a very good
I
job.
really like him.
Yeah.
Wait, so for the last value, I rated
Do I have to show my work?
the lowest value I rated was 12.
I read Xander.
It's the so start with the. So again, if we look at the example we did before, the biggest value gets the smallest rank. So you start at the biggest number with 1, and then you just number down from there.
Okay. Thanks.
So the biggest is first.
You don't have to write it in C, right?
Yeah, that's just going to be like a step on your calculator.
It's the past time of year again, December semester, what you should wear to Halloween, you know.
It's the numbers.
Luke, what are you dressing up for us on Halloween?
Me?
What are you dressing up as? Should we dress up as something for this class and get extra credit?
I hadn't planned on it.
Huh?
If you come up with a good math punned costume,
I have a really good one. What if I wear orange and
don't tell me beforehand. I want it to be a surprise on the day.
is it good?
I-
don't even know if it's good.
Look, you're just gonna have to take a risk.
We could do a party last year. Good idea. Seriously. For us. I wear orange.
Well, no. I just want it to be a surprise. Don't tell me beforehand. I don't want to ruin it.
Wait, is Matthew even on? Is Halloween? Yeah, it's on a Tuesday.
You can just pop in and show me, even if you didn't have class.
Like, what are you dressing up as?
What's X? What's X?
Me. I just try to be myself in really every situation.
Can I give you a costume?
Give me a costume.
Yeah. A math costume. Really good idea.
Yeah, but like, which one do you do for the?
I think you should dress up as an apple, but then draw
You just pick one value.
on your shirt. Then your apple pie.
You just pick one value. They they are.
Good?
You just pick one.
Not bad.
Do you dress up like,
And then you average the R
dress
value.
up something?
I've given up dressing up.
Now quit this class. That's so stupid.
Going to what?
Wait, I'm-
for Halloween. I just don't have it in me anymore.
Say that.
Life is too hectic.
I think, like, I have a couple more years left, probably around college, and then, if dressing up too late.
You do list 1 minus X bar.
Trigger treat.
I could get on board.
I did the one.
I could get on board dressing up like as a family costume with my daughter to go trick or treating. Mostly because my wife would take care of all the logistics of it, and I just would have to put the costume on and show up. Yeah, the planning part is the part that I just can't get on board with.
What is the family costume this year?
There is no family costume. We have yet to do this, but I would be willing to do that.
Aww. What's your daughter be?
She is a mermaid.
I know.
But she's getting to the age at least where she's like, I want
I
to
dress my own
costume. And I want to have
I don't know.
this.
Is it like a
Yeah.
She is 4.
But she's gonna start getting.
She's so independent.
Yeah, she put her own plate in the sink yesterday, so she's ready to kick her out of school. You know, like, go ahead, off into the world, get a job.
So what number am I supposed to get here? Because I don't think I got it.
The whole case was like.
For the spearman value,
No, for the rank one. I can do the rank one.
well, the rank order isn't a number. If you want the spearman value, I can tell you that.
Yeah, yeah. I don't know how to do E, but.
So your spearman should be a .902.
So I didn't get that. I probably did this one.
You said it's like
So how do you do it? You have to like do the rank thing, but I don't really understand the rank thing. It's very nice. I probably did it wrong.
You just do it like this.
That was so disrespectful.
Can you do it with James? 'Cause I already put the
Dude,
other
I'm
guys in
done.
my thing.
It's in bars. Bar stats.
Oh, I think I was actually looking at. No, me too. But I looked at the wrong thing.
I'm doing the ranks, but I think I messed it up.
How do you get the sick one?
Because there's no breaking or one.
Stop touching my ass.
That's because it's not 12, it's 10, buddy.
Wait, if there's two.
I have to give you my absent homework
Oh,
from like a bajillion years ago.
but you
Oh, gosh, we have to do like
Okay.
Wow, this was a month ago. These were both like.
Well, it's something.
Yeah.
Like, it would be
No,
like.
how do I get it?
Well, now that college apps are done, all I have to do is school, so like,
That's a relief, right?
yeah. Which is, college apps were like 90% of my problem.
Oh, yeah, I know what in the
Oh
world.
my god.
I'm totally.
So what is the next one?
Oh, you
Four?
bars. Wait, bars? No, you gotta go back. Bars. Statistics. No. Wait, what is this? Good. So that is. No, it's done. This works.
Okay.
Alexis.
I thought it was so bad.
Alexis, you said you didn't get the right Spearman number.
Probably not.
How'd you deal with the ties?
Oh, I did it wrong. I'm redoing it.
Mr. Cool, like, have you got Harry Potter?
I read the last book,
Just
just the last one.
You're full of surprises.
I'd seen like 2 of the movies.
Okay. How do you read?
That would be hard to
And
understand.
not any of the other.
Oh, I got the right one now.
I would not know it's movie.
I feel like that series is like.
Look, hold on a second here, guys. Hold on a second. You're talking about doubting whether I can pick up on enough context of a children's book to figure out what's happening beforehand. Yes, I'm more than capable of picking up enough context about like who things are. Like I'd seen like 2 of the movies or 3 of the movies. It's
I guess
fine.
yeah, they don't really tie back too much. Like you don't need
I
to see all the other movies.
Luke, I doubt you.
It's only a few.
I read them when I was in third grade.
It's not elaborate.
I think it was definitely okay.
This is what it got for me.
Have you seen how thick those are? Those are like very large.
Right, but like, let's be clear, like the themes and the plot are not like you need a map to keep track of who everybody is and what happened. It's like, you know, like 90% of it's like the atmosphere, and the story is rather simple. It's like every hero's journey story that you've ever heard before.
I feel like you're like.
I'm not. This is how, but this is what children's literature looks like,
Yeah.
right? Like it's simple.
I knew I had to average on that somewhere.
So the smallest, the biggest value is number
I would
one.
just
Yes.
both were 3.5.
What is the second Spearman's one?
Yes. Give me a sec.
The second Spearman's one?
3.5.
What do you mean, the second?
Like the last one was James.
The last one with James in it?
When you add James,
Oh, sorry,
no,
yes.
you're good.
So
It would, it would change to 0.511
yes.
and change.
Wait, what?
More than, and change. There's more decimals after 0.51.
0.51. The other one was 907.
Yeah, that sounds about right.
So how did it go from 5 to 1?
Because James's number is terrible.
Yeah, I got 5. I got 5 6s.
There's probably, so you would have had to, all of your tie ranks change.
Oh, I have to add it to the other. Oh.
Yeah, you had to include that new data point in your old ranking. So like
Okay.
more of your rankings are going to change or whatever. If you just did the R value, not the Spearman number, but the Pearson number, the Pearson is 0.48.
I watched Gossip Girl.
Oh no, that's the 15-minute timer.
I'm so confused now.
Oh. Sad that this question should take me.
All right. So let's talk through this real quick here, okay? We said the height. The height was independent. The weight was dependent because the taller you are, the more bones and stuff you have, the more weight you have to carry for connective tissue and skin and everything else. To get the R value, all I did was stat, calc, linreg, and I typed that stuff into L1 and L2, and then just pressed enter. So I have 868, or 865 for my R. Everybody's good? Okay. To do the rank order now, I copied L1 into L3 and L2 into L4 and then I sorted them from biggest to smallest. So that's here on my calculator. So, there we go. So my first place is 71, but it's tied, right? Remember how we deal with ties? So 71, I'm going to give the rank of, it's covering places 1 and 2. So it's going to get the average of ranking 1 and 2, which is 1.5. Oops, for 71. 70 is next. That's a tie at 70 for rankings 3 and 4. So 70s are going to get the average of ranking 3 and 4. Now we're at 5, that's 69. 6 is going to be 67, or 68, excuse me. And then 67, I got to see if there's a tie there. Nope. So 67 is then 4, and then 65 is 3, 64 is 2, and 62 is 1. Now we'll do the same thing with the weights.
What is 62 being 10?
Oh my gosh. Yeah, I started going the wrong way, right? Where did I lose it at? 5, 6, and then it should have been 7 after that. And I went down to 4 somehow. 7, and then this one should be 8, and that's 9, and that's 10. Thank you, Diego. All right, if I look at the weights, though, there's no ties here, right? Oh, Boise. Thought it was on the other screen. No ties on the weights, so I can just go straight down, which is lovely. So 218 is 1, 200 is 2, 196 is 3, 190 is 4, 188 is 5, 184 is 6, 170 is 7, 155 is 8, 138, and 136. So now in 5 and 6, I'm going to type in my rank order for the X's. So I'm going to go 7, and then 3.5, 1.5, 8, 1.5, 3.5, 6, 9, 5, 10. And then the same thing on my Y, so 8, 2, 1, 6, 3, 5, 7, 10, 4, 9. I'm going to exit out of here. I'll do that same stat calc linreg with L's list 4 and 5. I meant, is that what I did? 5 and 6? Thank you, Diego. 5 and 6. Okay. And there's my R value, 0.902, which is what I think I had said when you guys had asked me. Everybody's okay? Part E says, uh-oh, we have to add in one more data point. So I'll go back, edit. Yeah, that James, what a booger. So James, I'll put in at 61, and then 208. And that's not a big deal for the Pearson statistic, because I just rerun my linreg again on L1 and L2. And there's what it did. Boy, James is a real outlier there. And then to do the Pearson, though, that's like a big hassle. So he would get the number 1, right? What is his? Oh, no. He'd have the number 2 weight. So all the weights would move down 1 after that. So let's see if we can do this without having to redo everything. The weights will be easier. So this is now so the last value is going to be 2. 1 stays the same, and then everything after that picks up 1 unit, right? So 8 turns into 9, 2 turns into 3, 1 stays the same, 6 turns into 7, 3 to 4, 5 to 6, 7 to 8, 10 to 11, 4 to 5, 9 to 10, and then that stayed the same. His height was 61, which thank goodness for that. All that just does is turns into the 11 at the end, so no big deal there. So stat, calc, linreg, and then we did this on 5 and 6. And I get the 0.511 for the Spearman. And then there's one more problem, but I don't want to worry about it right now because quite frankly, we have like 7 minutes left and you guys feel pretty whooped right now, huh? Okay. So a reminder for Sunday, what is the problem set that we're looking for from you guys? Let me double check here what I put in here. So I'm just looking for the 14.1 homeworks, that's 1 through 10 on page 469. The 4.2 and 4.3 homeworks will be for next weekend. I'll put that in there also. Don't forget what else is due next week? Introduction. How do you submit that?
Via email.
Email. Does it have to be formatted in a specific way?
Absolutely.
Absolutely. Where do you find the format for how to send that in?
OneNote.
OneNote.
That's the first thing I got.
Good job, Luke.
It's on there.